Alright, we're back continuing our discussion of Chapter 3. In Section 4 they talk about line charts. Line charts are very useful tools if we're dealing with time series and we want to try and spot a trend, or we can actually look at several of these things at once. Typically, if we're going to do that, we have two different scales. Here you'll notice we've got dollars per month on the left axis and minutes per call the right axis, and so the red is the average call length, so that's going to be on this axis on the right, and the left is average monthly bill, so that's going to be the axis on the left. This is called a multi-scale or a two-scale line plot, and these are very good for making comparisons, but you do need to keep in mind that the magnitudes are different for the two different scales. So just because they mirror each other at some point doesn't necessarily mean that that's what's going on in the big picture. These are typically used with time series data, and we're not going to do too much in this course with that, so I'm going to skip over these next couple of slides and move on to talk about bar charts. A bar chart is exactly what it sounds like. We have a bar that represents the frequency or the relative frequency of each of the values. So we can use either a vertical bar chart or a horizontal bar chart, and you can see examples of both of these for the same data. And this is using ordinal, or rather nominal data, where we don't really have a difference between Goodyear, Firestone, Michelin, General, BF Goodrich, and so forth. But if we do a bar chart with the most frequent value first and then decrease that, so here we've got food cold, and this is concession stand customer complaints, so the food's cold, that over 30%, and then it drops down to too much time in line, and no vegetarian choice, and so forth. This is what we call a Pareto chart when these are put into order, and oftentimes we're given a cumulative percentage that goes along with that. So we've got descending order of the frequency, and this is generally when we're going to focus on a significant few in the front, and we don't really care too much about what's going on out here, or rather, what are the major players? It's these three here, and the rest of these are kind of minor in comparison. Here's something called a stack bar chart. If you're going to put all the numbers in here, you'd probably be just as well off doing a table instead. So this is not a really good sort of visual chart to be using. And that brings us then to the pie chart. And the pie chart is generally not looked upon favorably because of several different reasons. The first one is that it's difficult for the human brain to look at a slice of pie and get an idea of what that percentage is represented by. And so oftentimes we are left with having to actually put the actual percentage in with these things. And if we're going to do that, we may as well just use a chart or a table. Not a chart, but a table. Here's a pie chart versus a horizontal bar chart. Horizontal bar charts are not very good either. So I guess what I'm saying here is neither of these two charts are really that good. So you'd be better off using something else. The worst type of pie chart is something called a 3D pie chart or exploded pie chart, and I have no idea why people think these are cool, but the only time you really want to use one is if you want to overemphasize or exaggerate the percentage that one of the categories is getting, and you do that by putting that thing right in the front. This is only supposed to be 10%. This is 10%, but this looks more prominent than this. But they both look bigger than 10%. And part of that is due to the fact that you've got this leading edge here. So 3D pie charts are garbage in my opinion. I would never use one. Same with pie charts. I guess they're pretty and colorful, but in terms of conveying information, if you have to write the number in addition to drawing a picture, that's a pretty good indication that the chart's not really doing anything for you. Scatter plots are, on the other hand, something that are very valuable, and we look at these when we have two variables. In this case, we've got an x and a y, and we can look at the relationship between these things. So we can measure things like correlation. These are highly correlated, strong positive, a weak positive correlation here, and no pattern or no correlation here. In other words, if I wanted to say something about y, knowing what my x is doesn't help me. Whereas over here, if I know what x is, that helps me understand what y is. This is an example of a nonlinear pattern, and probably has a correlation that is close to 0. We'll talk more about correlation later on. Tables are another form of data display, and a compound table is one that contains time series data down the columns and variables across the row. There seems to be a lot of emphasis on time series. I assure you we're not going to do very much at all with time series in this course, but as an example, we can look at school expenditures, and the arrangement of the data is in the rows and columns to enhance the meaning. The data can be viewed by focusing on the time pattern down the columns or by comparing the variables across the rows. So here is what we're talking about. We've got the year down the left side, and then all schools, public, private, total, colleges, universities. So it's easy to come over here and look and see what's going on. School expenditures by all schools looks like it goes up over the years for public as well as private, and colleges and universities. It's pretty easy to see that expenditures don't ever go down in any of these for any of these years in any of these categories. Notice that we have the units of measure stated in the footnote, and this is the type of table that could easily be made into a bar chart or a stacked bar chart or a multiple bar chart, where each of the years 1980 has 1, 2, 3, 4, 5 different bar charts, or 5 different bars associated with each of them. We're going to finally talk about deceptive graphs, and this is the topic of section 9 from chapter 3. And the first thing that that we should note is sometimes graphs and charts and numbers can be used for ill-gotten purposes, and trying to mislead people and sell products that maybe are not as good as what they should be. Here's an example. On the left, if you look at this average length of cell phone calls, it looks like there's quite an increase from 2006 up to 2012. And the thing that you want to always check is whether the y-axis goes down to 0, or where that ends. So here we're looking at just the very top of this thing. If we look at the entire scale, it doesn't look quite as impressive. So here's the 2.1 right here, and so yes, it's increasing, but not as drastically as this is made out to be. Another thing that can be done is to stretch the aspect ratio, and and you can see here that the x-axis is stretched out considerably over here, and it looks like there's a nice little gradual increase. But when we look at the same data with the same with a different aspect ratio, then we get what looks like to be a much steeper increase. So those are, again, things you want to look at. Excel uses a default of 1.68 for the aspect ratio, but you want to keep that number below 2. Another thing that you can use are these 3D plots, 3D bar chart, 3D pyramid bar chart. It doesn't really make sense to use a three-dimensional measure for a one-dimensional, or three-dimensional display for a one-dimensional measure, but this is in Excel and lots of people use it all the time, and so what's really going on here is the eye is looking at this and saying, oh, this is very large. All these other things are very small, and that's true, but this gets exaggerated and looks even bigger. If you're doing a pyramid, it's not quite as, it doesn't quite tell the same story, although it is the same data. It's hard to see exactly where this top of this thing is, and even if I can see it, it's very difficult to trace it over to the x-axis or the y-axis, because you get this sloping line here, so you have to go straight back. Where does it hit? I can't even tell where it hits, and then follow that forward over here. This is not that much different. You have to go straight back here, hit it here, and then come right up here. So just if you're doing these sorts of things, don't get fancy with the 3Ds, and the novelty graphs are annoying at best and misleading at worst. Here's another example of the scale, the y-axis being off and exaggerating what's really going on here. So we're starting at 30,000. We're rotated. 3D makes it look like there's really significant difference between these years. When we actually look at all of the data, yeah, it's still going up, but not as drastic or dramatic as it appears here. Here we've got an example of way too many categories to be dealt with effectively, and the chart looks pretty with all the different colors, but it's very difficult to know what the proportion of orthopedics is, for example, here without putting the numbers. And again, if you're going to do that, you may as well just put the numbers in, make a table instead of a chart. Another thing that's done sometimes is to increase the not just the height but the width as well, and that makes 2010 look bigger than it should. And we're used to looking at these things and talking and thinking, instead of just the height, actually looking at just the height when we have the width varying as well. It gives overemphasis to that one. So don't use those sorts of tricks, even though they're easy to do in Excel. So that's all we've got for Chapter 3. Look for videos for Chapter 4 for this week, and we'll see you in the next video.